Our notes today are called linear stuff. Reminders about things related to linear stuff. Is that the technical term? Of course not. Are you okay with it? Good. Okay. All right, here's where we're going to start. See this guy? He's going skiing for the first time. He's never been before. He's super excited. What's he doing right now? He's riding up the ski lift, right? Okay. He accidentally got off on a black diamond from the ski lift. What does that mean? Super hard, right? It's the hardest one. Is he excited anymore? No, he's terrified. Can you see he's screaming? His mouth is open so wide he's screaming. Somehow, he made it to the bottom. I'm thinking probably angels, right? But somehow he made it to the bottom. But he made it to this perfectly horizontal place of snow. Where is he going? Nowhere. He can't go anywhere, can he? Until a giant gust of wind came and blew him off the cliff. Yeah, his legs aren't even attached anymore, right? He's dead. Here's his hat. Oh, I forgot his hat on this one. Here's his hat over here. So, sometimes I like to tell you silly things to help you remember stuff, right? He's riding up the ski lift. He's super excited. As he's going from left to right, he's increasing, right? So what kind of slope would that line have? That's a positive slope. Rising from left to right is a positive slope, correct? Falling from left to right, he got off the ski lift on a black diamond on accident. What kind of attitude does he have now? Negative, right? He's terrified, right? Has a negative attitude. He might still have a positive attitude, but he's probably going to die, right? Or at least be maimed or injured. But overall, he has a negative attitude. Falling from left to right is a negative slope, okay? But like I said, somehow he makes it to the bottom, and he's on a perfectly horizontal place. What kind of slope does he have now? Like, what's his speed now? 0, right? Sometimes we call this no slope because it's perfectly flat. And then after the wind comes and blows him off the cliff, what kind of slope is this? Yeah, he's dead. He is undefined. Does that make sense? Is that a silly way to remember it? Yeah, especially with the dead guy over here, right? Okay. But if it helps you remember that rising from left to right is a positive slope, falling from left to right is a negative slope, a horizontal line being 0 slope, and a vertical line being undefined slope, it's worth it. Okay? Okay so far? Some more linear stuff that I need you to know. What's this? That is slope-intercept form. Okay? Not form. How about form? Slope-intercept form. In slope-intercept form, what is M? M is your slope. In slope-intercept form, what is your B? Your intercept, what kind of intercept? Your y-intercept. Specifically, your y-intercept is at 0, b. It's a point, right? It's a point on the y-axis. Why is it 0, b? If it's on the y-axis, how far left or right have you gone? Nothing, right? You've only gone up or down b units. Does that make sense? Okay. What about this? What's this called? Do you remember? This is called point slope form. In point slope form, what is this? Well, just like it is up here, what is it? It's your slope. And there's a specific point, x1, y1, that we're talking about. x1, y1. Okay, so far? Okay. What about this? ax plus by equals c. What's that called? Standard form. She just likes to whisper, I guess. I think we could all hear you. You have more of a stage whisper than an actual whisper, just for the record. Okay? Some more linear things to think about and to know. What's that the symbol for? Do you remember? It's for parallel lines, right? And what do you know about the slopes of parallel lines? Slopes are the same. What's that the symbol for? Perpendicular lines. And what do you know about those slopes? Opposite reciprocals. Okay so far? Is any of this stuff we've talked about today so far, is any of it new? How long has it been since you've talked about some of this stuff? A while. That's why we're talking about it today. Is that all right? Okay. All right. Okay to go on? There might be a question that shows up that looks like this. That's all it says in the question, so you know that's an expression because there's no equal sign. So it's not asking for to solve for x. It might say, which is equivalent? And it might give you 4 options. Well, do you need to know which are the options to know what is the answer to what's equivalent to this? No? What's the answer? How did you get there? Distribute. Is it going to say, use the distributive property to tell me which one's equal? No, it's just going to say which one's equivalent. Sometimes you might need to look at the answers to see what it's actually asking, but it's just asking for you to use the distributive property. Everybody okay with that? Comfortable with the distributive property? Okay. What about if it gave you a question like this, and your instructions were solve? Could you solve an equation like this? Oh gosh, I hope so too, right? So if I subtract 5 from both sides, I get x equals 4. Is that a problem that you might need to look at the answer choices to know where to go? Hopefully not, right? But if it was something, maybe there was a 2 here, maybe there was a parentheses involved, what could you do with the answer choices to figure out which? Yeah, you could plug them in and see which one made the equation equal, right? Okay, remember that's an option. Something might, one of the questions might say something like this. It might say S equals 200 plus R over 12. And the instructions would say, if S equals 500, what is R? Guys, I need you to understand that this question and this question are the same. But what it's asking me to do is slightly different, right? I have to take S equals 500 and substitute it in first, don't I? I have to say 500 equals 200 plus R over 12. Now do you see how these two would be the same kind of question? Because I have to subtract 200 from both sides to get 300 equals R over 12. And to solve for R, what do I have left to do? Yeah, well, what's the 12 doing to the R? Dividing. And what's the inverse operation from dividing? Multiplying. So if I multiply both sides of the equation by 12, what do I have left? R equals 3,600, right? Any questions about that? So of the 3 examples that I've given you so far, can you see how these are all linear in nature? This is a linear expression. This is solving a linear equation. And this is another solving a linear equation, but you had to substitute the 500 in first, yes? Okay. The last kind of problem second to last kind of problem I want to talk to you about today is a problem that might look like this. 12x plus 4 plus 17x minus 12 minus 24x plus 8x. What in the heck are they trying to do? Maybe a little tricking, maybe a little confusing, but definitely they're trying to overwhelm you, right? You're not going to let them. You're going to say, well, that's an x, that's an x, that's an x, and that's an x. I know I can combine all of those, can't I? Okay? Guys, the other thing is answer me this real quick. In your opinion, is this the kind of problem that a calculator might show up on? No. Because at this type of problem, they want to check your arithmetic. Can you add and subtract? Okay. Can you really be considered college ready if you can't add and subtract? Probably not, right? There might be some way around it, but probably not, right? So what is 12 and 17? 29. This is why we have our scratch paper, right? And then we have minus 24. And then I have plus 8. So what am I writing first? 13x. Now, is it okay if I didn't put the x's over here on all these that I did? Yeah, I was just combining like terms. I know it's going to be an x, okay? And then I have a 4 and a negative 12. So minus 8. You okay with that? Okay. So your worksheet for today. Okay, that's the main linear stuff besides the worksheet for today. The worksheet for today deals with slope. We talked about it a little bit a minute ago when we talked about parallel lines and perpendicular lines. I wrote all this stuff up here that I thought of that I could think of when I was thinking about slope. Slope is m. Slope is rise over run. Slope is delta y over delta x, which means change in y over change in x. And then there's the two formulas that you can use. They're exactly the same. They're just flipped, right? Okay. When finding a slope from a given graph, find 2 points and count. So on this one, I would count. Rise, 1, 2, 3, 4, run, 1. So my slope is 4 over 1 or 4. Yes? If you're given 2 points, when finding the slope between two given points, label your points, x1 and y1, and then just choose one of these two formulas at the top that are the same to plug it into. When finding the slope from an equation, put the equation in slope-intercept form and then find m. Where is m always going to be? With the x, right? Now, if it's in slope-intercept form, is it first? Yes, right? But if it's not in slope-intercept form, where is slope always? With the x, okay? The second example I showed you, if it's in standard form, how to get it in slope-intercept form to find your x, or find your m. Does that make sense? Okay? Now, on all these problems that you have to do today, first of all, you have to find the slope. Second of all, for odd problems, you're going to find the slope of a line parallel to that line. So if I know the slope of the line is 2, what's the slope of the line parallel to that? 2. It's also 2, right? But for even problems, find the slope of a line perpendicular to that line. So if I know that my slope is 2, what's the perpendicular line slope? Negative 1/2, right? It's the opposite reciprocal. Flip it over, change the sign. Does everybody understand that? Any questions on this? Any questions on any of the linear stuff that I talked to you about today?